Okay, so two things I want to just take a quick look at. One of them, I'm not going to spend really any, I'm just mainly going to give you a list of the divisibility rules. Thank you. That's for you. Whoops. Uh-oh, sorry. There you go. And maybe there's one of them I'll show you, but the rest of them are pretty self-explanatory. And then the main topic of the day is, in preparation for the 5.5 practice, which is, all it is the same stuff you've been working on in a context. Instead of just factoring in a vacuum, you're going to be factoring to solve polynomial equations. So actually using factoring to do something, right? Okay, so divisibility rules. So divisibility rules, we've got rules for all of the numbers 2 through 10. Most of them you probably already know, and they're very simple. Obviously, if a number is even, it's divisible by 2. You guys probably know this one, right? If you have a big number, you can sum the digits, and if the sum of the digits is divisible by 3, then the number is divisible by 3. Give me thumbs. You guys know that one, right? You're familiar with that one. So, for example, just in case you're not, like if I take the number 723, if the sum of the digits is divisible by 3, then the big number is. So, for example, 7 plus 2 plus 3 is 12, which is divisible by 3, so the whole number is, okay? For 4, all you have to do with 4 is just look at the last 2 digits of the number. That's it. So, for example, if I had a really big number like because 24 is divisible by 4, the whole number is, right? Why does that work? Because 4 divides evenly into 100. And so really what do I have here? I just have a whole bunch of hundreds plus 24, right? So again, the divisibility rule for 4 is just only look at the last 2 numbers and ask, are those 2 divisible by 4? 5, you know, that's an easy one. 6 is just a combination of the divisibility rules for 2 and 3. So it has to be even, and the sum of the digits has to be divisible by 3. 7's a weird one. Let's look at 7. So for example, let's see. Like if I take a number like 3192, how about? Here's how you can pretty quickly tell if a number is divisible by 7. You take the last digit, you double it, and you subtract it from the remaining digits. And you just repeat that until you get a number that's either divisible by 7 or it's 0. So 2 doubled is 4, right? So I'm just going to subtract 4 from 319, from the remaining digits. And that's going to give me 315. Maybe we still don't know if that's divisible by 7. So we'll do it again. If we double 5 and subtract it from 31, we get 21, which is obviously divisible by 7, okay? And we can stop, okay? Give me thumbs on that. Does that make sense? Okay, that's kind of a handy one because 7s are tough. Divisibility rule for 8 is just like for 4, only you look at the last 3 digits. Divisibility rule for 9 is just like 3. If you sum the digits and the sum of the digits is divisible by 9, then the whole number is divisible by 9, and 10's obvious. If it ends in a 0, it's divisible by 10. So I'll add these to the notes today. They'll go up on the notes. If you want to see these again, if you just go to Plan Book, there's a PDF of the notes for today that'll show up. Okay, so I want to look at 3 examples then for today, and that's it. We just want to look at solving 3 polynomial equations, and this will give us some good review for the assignment, okay? What do we always do first when we're solving a polynomial equation? Set it equal to 0. We've got to put it in standard form. So we're going to push everything to the left side so the leading term would be positive, right? We want the biggest power of x to be with a positive coefficient. So if I subtract 48x, I just get 3x to the 5th minus 48x equals 0. Okay, what's next? What do we always, now we got to factor, right? What do we always try to do when we're factoring every single time? GCF, yeah. Can we undistribute a GCF? Yeah, I can take out a 3 and 3x, perfect. Okay, so. And what's left behind if we do that? X to the 4th minus minus 16, okay. There we go. Equals, oops, what did I do there? There we go, equals 0. All right, so now we've just got to keep, we're to the point now, once we put it in standard form, we've just got to factor until we have the option to stop. How do we know when we can stop? When our factors are x squared or linear, when they're quadratic or linear. So the biggest power of x in our factors would have to be x squared for us to stop, right? Can't stop. X to the 4th is too big, right? So I've got to break down the blue factor. How would I approach the blue factor? It's a binomial. So how do I factor binomials? How's that work? Ashley, got an idea? Difference of squares. I'd have to use one of my patterns, right? And I only have 3 patterns. Difference of squares, difference of cubes, and sum of cubes. And remember, there is no sum of squares pattern. So this one would match a difference of squares, wouldn't it? So this would look like x to the 4th just looks like x squared squared. 16 is just 4 squared. And what would that pattern be then? A squared minus b squared factors into what? Okay, good. So a minus b times a plus b. My a is just x squared and my b is 4, right? So we're going to get x squared minus 4, that's my a minus b, times x squared plus 4, that's my a plus b. And then don't forget, out front, we've got our monomial factor, a GCF. And the whole thing is equal to 0. Okay, now really we're good. I mean, we have an option. We could try to factor more, or we could just stop. We could just bail off the factor train here and set those equal to, set each factor equal to 0 and solve. What about the 3x? What's the 0 of that monomial? 3x equals 0 when x equals 0, sure. Okay, so there's, and anytime we have a monomial factor, the solutions, the 0 of that monomial factor is always going to be 0, isn't it? So there's one solution. How many total should I get? 5, yeah, good, because it's a degree 5 polynomial, right? What about the x squared minus 4? What are my options? I mean, I could just isolate the x. To me, that's easier. Or I could break it up as a difference of squares, right? That's x squared minus 2 squared, and so I could make that x minus 2 times x plus 2. Either way, I think personally it's easier just to, I think it's easier just to set it equal to 0 and isolate the x, don't you think? What the 2 steps, pretty simple. 2 steps to isolate the x, I just add 4 and square root. Everybody agree? So we end up with x squared equals 4, so x equals what then? Plus or minus 2 when I square root both sides. And I get the plus or minus because I'm square rooting both sides, right? So I got to include that plus or minus. Okay, good. And then the last one, I don't have a choice because there is no pattern for this one, right? This one's a sum of squares, x squared plus 2 squared, which doesn't factor. So we've got to just set it equal to 0 and solve. So if we do that, everybody agree we're just going to get x squared equals negative 4. So what's that going to become then if I square root both sides? but not just 2i, it's plus or minus 2i. Good. Plus or minus 2. And then the I comes from the square root of the negative 4, right, when I square root both sides. Okay? So there are my 5 complex solutions, right? 2, 4, 5. Give me 1 to 5 on that. How are we doing? Okay? Good? Good. Okay, how about this guy? What do you think? What are we going to do first? Set it to 0. Good. Good. So we're going to subtract the 5 to the left side. And that's going to give us 8y to the 4th plus 18y squared minus 5 equals 0. Okay, we got a trinomial, right? We got a trinomial equation. It's not quadratic, but for us to proceed with this, we got to be able to make it look quadratic. Can I make that look like my values of a, b, and c are 8, 18, and negative 5 in that trinomial, right? We got to make it look like 8 times something squared plus 18 times something minus 5. What would the something be? What's it going to be? Again, we just got to make it look like this, right? We've got to make it look like 8 times something squared plus 18 times something to the 1 minus 5 equals 0. Now, if those were x's, we'd be back in Unit 4, right? It'd be just a simple quadratic equation. In Unit 5, they're not x's, they are what? Say it again. Y squared, right? Because what squared is y to the 4th? Y squared is. Okay, give me thumbs on that. Does that make sense? Okay, so then this really is this is a Unit 4 problem, only when we solve this quadratic equation, instead of solving for x, we're solving for y squared this time, right? So we can solve this one. There's really 2 ways we could do this. We could use the quadratic formula. That's fine. We could use, a is 8, b is 18, c is negative 5, and I could use the quadratic formula solving for y squared, or I actually could factor this. Are there magic numbers that multiply to AC and add to B? That multiply to negative 40 and add to 18? Are there? And again, do you guys see how we could use the quadratic formula here? Right? I would just have, instead of having x equals negative, I'd have y squared equals negative. And I get 2 answers for what y squared equals. Okay, but let's just go ahead and factor this just for some practice. Who uses factoring by grouping to do trinomials? Who uses slip and slide? You got to pick one. If you're factoring trinomials that are harder trinomials, do you use slip and slide, or do you just break it into 4 terms and group? I showed you both ways. Grouping? Okay, again, just vote. Show me hands so I kind of know where we are. Who factors by grouping? Okay, who factors by slip and slide? Okay, the majority. Okay, so we'll do slip and slide then, because most people do that. All right, so we got to do a little side work here. We got to do a little side work on slip and slide then. So what's the first step of slip and slide? Okay, good. I got to multiply a by c. So I'm going to multiply the 8 by the negative 5. And then that's going to give us just plain old y squared. Whoops. Y squared squared plus 18y squared minus 40 is what we get on the left side. And that's all we're trying to do is factor the trinomial. There's step 1 of slip and slide. What's step 2? Let's number these. There's step 1. What's step 2? We got to factor that basic trinomial. Good. So we're going to have to break this up. What's going to go there and there? Y squared. Good, because when I distribute, I need to get y squared squared, or y to the 4th. So those are y squareds. Now, can you find magic numbers that multiply to negative 40 and add to 18? 20 and negative 2. Very good. So plus 20 and minus 2. Now what? Good. Divide by 8. So step 3 is we're going to divide each magic number by 8, by a. And then last step. Okay, but first I need to, you got to reduce the fractions if you can, right? So we're going to get 20 over 8 just reduces to what, 5 halves? Negative 2 over 8 is negative 1/4. Negative 1/4, last step. Okay, good. Slide the denominator up. And then we got the left side factored. So what do we end up getting then? We get, this is going to break up into y squared times 2, right? So we get a 2y squared plus 5 times 4y squared minus 1 equals 0, right? And now all I've got to do is just set those two, set them equal to 0. The two factors equal to 0 and isolate y. I could factor this one with difference of squares, but you don't need to. You can just set it equal to 0 and solve that simple quadratic equation by isolation. So let's do those last steps. How about this first one here? If I set that equal to 0, you guys can do this one in your head. What am I going to get if I subtract 5 and divide by 2? Okay, so negative 5 halves. So y squared equals negative 5 halves. So when I square root, what am I going to get here? Y equals, fill in the blanks for me. Okay, but before I do anything else, if I'm square rooting both sides of an equation, plus or minus, so I've got a plus or minus, and then the negative inside becomes I outside. And then I've got kind of an awkward thing. I've got a square root of 5 halves, right? Which is the same thing as the square root of 5 over the square root of 2. Okay, but what rule am I violating there? Ah, good. No tenths in the basement, right? Can't have any square roots in the denominator. So what do I have to multiply top and bottom by? Square root of 2. Good. Okay, and then so what do we get for our final answers then? So we get y equals plus or minus. On the top, square root of 5 times square root of 2 is square root of 10. We're just multiplying inside numbers. Square root of 2 times square root of 2 is 2, right? So plus or minus the square root of 10 over 2, I. Give me thumbs. How's that? Okay, there's 2. Good. So there's 2 of our 4 answers that we need, 4 solutions. Because remember, the polynomial is degree 4. And then the other two are a little bit easier. If I set the other factor equal to 0 and solve, I'm going to get y squared equals 1/4, right? So this one's a little bit easier. What am I going to get if I square root? Plus or minus square root of 1 over square root of 4. And what is that? 1 over 2. Okay, 2, 4. There's my 4 solutions, right? Okay, give me 1 to 5 on that. How we doing? Oh, good. I like to see that. That's good. All right. Okay, last one. I gave you kind of a doozy on the last one. This will be good practice. All right. So now it honestly looks a lot scarier than it is. Yep. Yeah. This problem, is that bad? Okay. It looks a lot worse than it is. And sometimes polynomial equations do. Because when I put everything on one side, I'm going to get lots of like terms that combine here, right? So I'm going to push everything to which side, first of all? Probably the right side. How come, Trey? Good. I have a positive leading term. My leading coefficient would be positive, right? So we're going to push everything over to this side. Now let's keep a running tally of what we get here. So on the right side, if I add 33x to the 5th to negative x to the 5th, what's that going to give me? 32x to the 5th. Okay, what if I add 8x to the 4th to nothing? I just get 8x to the 4th, don't I? What if I add 2x cubed to negative 2x cubed? Yeah, those guys just cancel, don't they? Right? So the x cubes go away. That's good. If I add 108x squared to no x squareds, I just get plus 108x squared. And then, let's see, finally, if I add 31x to negative 4x, I get 27x. And the whole thing is equal to 0, right? Okay, so we got an ugly looking polynomial equation. What do we always try to do first? GCF, good. Okay, so what is our GCF here? So I can take out, let's see, I can take out what number? I guess no numbers, huh? Just an x, okay. So we got just an x, and then if I undistribute an x, I'm just going to get 32x to the 4th plus 8x cubed plus 108x plus 27. Okay, that looks terrible, but we know what to do. If I've got a 4-term polynomial, how do I factor a 4-term polynomial?
Not algebra 2.
No, it's algebra 2. How is it again? By grouping, yeah. So we're just going to break this thing up into 2 groups of 2, right? So there's our division bar. We got our first group and our second group, okay? Don't forget now, this looks kind of confusing because we've got this x, this GCF that's an x outside. So everything else we're doing is going to be kind of grouped inside these white brackets, right? We're trying to turn that 4-term polynomial into a product of smaller polynomials, okay? So we've got this x out front. We're done with it, but it's still there. And then inside my brackets, in group 1, what do I do in group 1? Okay, I'm going to take out an 8x cubed. I'm going to take out my GCF from the first group, which is an 8x cubed. Okay, what's left behind then if we undistribute an 8x cubed from group 1? 4x plus 1. Okay, now let's not forget we've got to put a plus in the middle between the 2 groups. What do we know has to be true in group 2 then? Okay, good. In order for it to work, we have to have a 4x plus 1 over here. Is this one going to work? We can tell it is. How come? There you go, right? Because the ratio of the first two coefficients is equal to the ratio of the last two coefficients. 32 over 8 is 4. 108 over 27 is 4. So we know it's going to work, guaranteed. Okay, for this to work, what would I have to undistribute? 27, yeah. I'd undistribute a 27 from group 2, right? Okay, so now we're actually, well, we're almost done grouping. We're not quite done grouping. So we've already got this x out front. What's going to join the x out front? What else is going to get factored out of each group? The common factor, which is 4x plus 1, right? That's the one that's always going to be the common factor. So that one, so the 4x plus 1 is going to get pulled out front too. So now I've got two factors that have been factored out front, the x and the 4x plus 1. And what's left behind inside the brackets? Inside the white brackets. Yeah, I've got an 8x cubed plus (27). Okay, that's good. We got two of them. The yellow factor and the blue factor are done. What about the red factor? Sum of cubes. We can't stop because it's cubic. It's not quadratic. It's not small enough. So the only way to deal with this one, it's a binomial. We have to use one of our patterns, and the pattern that fits is the sum of cubes pattern, right? Okay, so let's remind ourselves real quick about the sum of cubes. A cubed plus b cubed. Tabri, how's that one factor? Very good. Okay, so there's our pattern. So this is going to look like, instead of an 8x cubed, what quantity is being cubed there? 2x. So that's our a. And 27 is just 3 cubed, right? Okay. So then that's going to split up into what? 2x plus 3. So there's my a plus b. Now be careful. What's my a squared? 4x squared, right? Because I'm squaring 2x. So I get 4x squared minus 6x. A times b. 2x times 3 is 6x plus 9. There you go. Okay, and then we'll bring down these other guys to join those factors. Okay, and there it is. Okay, so now that looks ugly. Admittedly, that looks a little ugly, but it's all factored. We don't have to go any further, right? So let's look at these one at a time. What's the 0 of the first factor? 0. There's one solution. What's the 0 of the second factor? You can do it in your head. If I set it equal to 0 and solve, what am I going to get? Almost. Negative 1/4. Subtract the 1 to the other side, divide by 4. So there's two factors. Third one's easy too. What's that one going to be? Annika, what's that one going to be? Help me out here. Negative 3/2. Excellent. So negative 3/2. Now finally, how about this last guy? Let's look at this one. So we've got a trinomial. The trinomial factor from our difference of cubes, sum of cubes pattern. Is it worth trying to find magic numbers? Trying to factor it? It'd be a total waste of time. How come? that trinomial factor, whenever we do a cubes pattern, sum or difference of cubes, we always know that, remember that the trinomial is going to be irreducible, which means we're always just going to use the quadratic formula, right? Okay, so we're going to use quadratic formula for that last one. All right, so let's do that. If I set that equal to 0, and apply the quadratic formula, what's it going to give us? X equals, what goes on top of my bar? 6 plus or minus, right? Square root of minus 4 times 9. So that's 4 times 36 is what, 104? Or 144? And then on the bottom I've got 2 times 4 is 8. Okay? So that's going to be 6 plus or minus the square root of negative 108, all divided by 8. Well, let's go ahead and split that denominator. Oops. Right? And so we're going to get x equals 6 over 8 plus or minus. Now, the square root of negative 108. How about the square root of 108? We could make that 36 times 3, right? Agreed? So then what's that? If it's the square root of 108 is the square root of 36 times the square root of 3, what's that going to become? 6 radical 3. Okay, good. So we're going to get plus or minus 6 times the square root of 3 over 8. And then the negative inside becomes an I outside. And so if we just reduce our fractions there, 6 over 8 reduces to 3/4. And so I'm going to get 3/4 plus or minus 3 times the square root of 3 over 4. And again, that's just because we've got that 6/8 that we can reduce, those outside numbers, right? Times I. So that's 2, 3, 4, 5. We got them all, didn't we? Okay. Let me get them right. Let's see. Looks like we got them right, didn't we? Okay. Give me 1 to 5. Okay, probably just need some practice, I'm guessing, which you can do right now. 5.5 assignment is up. So go.